Let's talk about t-distribution here. In this graph, you can see the probability density function of t-distribution versus z-distribution or standard normal. And one point that is very visible here is that t-distribution is more variable and has more variability than standard normal. You can see it's a little more spread out. And therefore, the 95% probability limits are a little wider than for the z-distribution. And that makes the confidence interval of t-distribution also a little wider. So whenever it's possible to use the z-distribution and do the z-test, it's preferable to do that as opposed to t-distribution. But as the sample size goes up, above 30, t-distribution is a good approximation of normal. So that's why after that point, we replace the t-test with z-test if n is greater than 30. So just keep that in mind that t-distribution is having the same symmetrical shape of standard normal, but a little wider. And you can see the limits on the random variable starts at 0 and goes 1, 2, 3, 4, and more. So what we want to learn about t-distribution is how to calculate probabilities, right? For example, suppose t has a t-distribution with 7 degrees of freedom. We'll talk about that. Find the following. Probability that t random variable is more than, let's say, 2.365. By now you probably can guess that we probably have another table just like what we had for standard normal for t-distribution, and we're going to use that table. So let's go to the table and take a look at t-distribution table. So here's the t-table, and as you can see, it's kind of similar to z-table, but it's different. First of all, the first column that you see here, this column here, is nu, this Greek letter nu, and that is the degree of freedom that you saw before. That is the degree of freedom parameter. And then the first row is alpha, and alpha is actually probability. And this is something that is different from z-table. In the z-table, the probabilities were within the table. But here, the probability is on the first row. And alpha is, as you can see in the graph here, is this area under the curve. And it's the area to the right of the random variable. So if this is t of alpha and nu, alpha is the area after that random variable under the t curve. So this is the first column is degree of freedom. The first row is alpha, or the probability. What we see within the table, these numbers that you see within the table, these are t random variables. So now let's go back to the first probability that we need to find out. The first probability that we want to find out is probability of t greater than 2.365. Let's see how we can read that from the table. So probability of t greater than 2.365, that means we're basically, if you think about the t-distribution graph, 2.365, let's say, is here, and the area under the curve after is the probability that we want to read, t greater than 2.365. So what we need to do is, first of all, in the problem says degree of freedom is 7. Degree of freedom is 7, so we got to go to the 7th row. That's the degree of freedom. And we have to find this 2.365. So if you look at this row and move to the right, at one point you get to 2.365. And the probability associated with that here in the top, this is the probability that you're looking for. t greater than 2.365. Well, we know that the entire area under the curve is 1. So if you were looking for probability of t less than 2.365, you know what to do. It's 1 minus 0.025, which is this probability right here. So this is how we read probabilities. Probabilities are in the first row, and within the table we have the random variables. Okay? Now, let's look at the second question. Now, second one says probability of t less than negative 3.499. So, one thing that you need to remember is that the t distribution is symmetrical. And because of that, this probability, if you put it in the graph, this is 0 and this is t distribution, and negative 3.499, let's say, is here. That is the probability we're looking for, less than negative 3.499. And that is the same as probability of t greater than positive 3.499. And because in the t table, what we have is the area under the curve after these random variables, we can take advantage of that and basically say this is the same as probability of t greater than 3.499 and read that from the table. So let's do that. So we want to find probability of t at less than negative 3.499, which is the same as t greater than positive 499. Now, we know the degree of freedom is still 7, so we got to go to the 7th row again and find 3.499, which is here. Now, when you go up here, and that is the probability, 0.005, and that is equal to 0.005. That is the probability that we wanted. That is equal to 0.005. And that is basically this area. Now, part C says the value of x such that probability of t greater than x is 0.05. Well, we're looking for x, and x here is a random variable. We're given the probability. We're looking for the random variable value. So it's kind of a backward process that we need to do here. There is some, basically, if you want to again put that on graph, and this is a t distribution, this is 0. Probability of t greater than x is 0.05. So basically somewhere here there's an x, that probability of t greater than that area is 0.05. Degree of freedom is 7, so let's take a look at t table. Well, we're looking for probability of t greater than x is equal to 0.05. We're looking for x. Well, we go to the 7th row again, and this time we are given the probability. So we got to take a look at the first row to look for 0.05. And in the first row, we find 0.05 on the 4th column. Now, the x that we're looking for is 1.895, because probability of t greater than 1.895 is 0.05. So x is equal to 1.895. So here we say x is equal to 1.895. Now in part D, says the value of x such that probability of t less than x is 0.9975. Again, let's put that on a graph, on a t distribution. Here is 0, and probability of t less than x is that much. So basically, because this number is almost 1, we're talking about almost the entire area under the curve. So there's probably an x somewhere here, that the probability of t less than that, which is this area before x, is equal to 0.9975. Well, that means that this area after x is 1 minus 0.9975, right? Which is equal to 0.0025. So basically we can say that probability of t greater than x is equal to 1 minus 0.9975, and that is 0.0025. And we do this because in the t table what we have is probability of t greater than any value. Because of that, we need to change less than to greater than. Quite the opposite of what you used to do in the normal distribution. Now this time, we got to go to the table, look for this value in the first row, and read the x associated with that on the 7th row. So let's do that. Okay, this time we're looking for probability of t greater than x is equal to 0.0025. That's what we found. Now, you have to find this in the first row. This is this column right here. And when you come down from there to the 7th row, this is the random variable, or your x, essentially. The x that we're looking for is 4.029. So here we can say x is equal to 4.029. Basically, the number here is 4.029.